In this short video, I'm going to just quickly show you how the complex conjugate theorem can be used with a quadratic. And now I apologize, the question's a bit blurry. I tried to make it clearer, but unfortunately it didn't quite work. And now, whenever you do have a complex root, like 2 minus 3i, we can always say that the complex conjugate of this, which is what you get when you keep the real part the same, but multiply the imaginary part by minus 1. So in this case, that's 2 plus 3i. So for example, another notation you may have seen is if z is equal to 2 minus 3i, we can say z and then a star is equal to 2 plus 3i. That z star just shows that it's the complex conjugate of z itself. Now, once you have these two roots, you can form a quadratic. Think about it like this. If you had x equals 4 and x equals 2 as a root, you'd form a quadratic saying x minus 2 and x minus 4, wouldn't you? You'd do something similar here. You'd do x minus, and then in brackets, I'm going to put 2 plus 3i for one root. It's important that you put in brackets because otherwise students forget to multiply both terms. And then you multiply onto that, x minus, and then another bracket with 2 minus 3i. Now, okay, so we've actually done part I. I just realized it's 2 plus 3i. But to find the values of p and q, once you've simplified it, factorize it, into this scenario here, you then want to multiply out the brackets. So we have x minus 2 plus 3i. And then we also have, oh, actually, I think I've spotted an even easier way to do this. So once you have it in this format, you can just go on to expand on the bracket. X times x is x squared. X times all of this is minus x, and then in brackets 2 minus 3i. And then we have minus 2 plus 3i, all multiplied by x, so that's going to be minus x lots of 2 plus 3i. And then this term here, let's do this a bit off to the side. We have minus 2 plus 3i multiplied by minus 2 minus 3i. Now the minus and minus cancel out, and this is essentially the difference of two squares. 2 times 2 is 4, and then 3i times minus 3i is minus 9i squared. You don't need to worry about the terms in between, like 2 times minus 3i or 3i times positive 2, because they cancel out. Now, because we know I squared is equal to minus 1, we can write this out as 4, and then minus 9 times minus 1 is positive 9. So that would all equal 13, meaning that that last term would be plus 13. Now, these terms here, let's be a little bit careful with simplifying this. Again, I would advise doing it a little bit off to the side and then joining it all together. So when you expand out that first term, we get minus 2x. Minus x times minus 3i is plus 3xi. Minus x times 2x is another minus 2x, and then minus x times 3i again is, but this time it's negative, so it's minus 3xi. What we see is that the xi terms cancel out, whereas the x terms, minus 2x minus 2x, add together to give you minus 4x. So ultimately we get x squared, this whole expression here being minus 4x, and then plus the 13 that we got from before. We've now made it into the format that is asked for in the question, and we can deduce that p, the coefficient of x, is equal to minus 4, and q, the coefficient of the constant at the end, is equal to just positive 13. And that's it. That's everything for this question. Be sure to leave a like if this video helped, and subscribe. I'd appreciate it a lot. Thanks for watching. Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excellineducation.co.uk.